Thank you, Detlef. Good morning, everybody. I'm presenting what we do in Europe on the subject of planetary defense. And we are a small office. Detlef and myself are heading this. Can maybe all the ESA members of the Planetary Defense Office stand up and show your face? So most of the team is here. As I said, it's a small office, but we try to do as much as we can with our limited budget. So we have three pillars. The first one is observing. We heard this before. We need to find the objects, but once we have found them, we have to analyze the orbits. We have to calculate the impact risk, and we have to do basically to provide this information to the public. And the third pillar is mitigation. What can we do against a possible threat? On the ground, we have the ground and data system support, so we need IT support to make this all happen. So the first pillar is observations. On this map, we see all the telescopes with whom we are collaborating. The blue ones are the two which are currently under development. The A in Sicily is the Fly-Eye telescope. Oops, no, that was, here's the, you have to, yeah, here I am. So here we plan to put the Fly-Eye telescope, and in Chile we want to have in the southern hemisphere a testbed telescope. The red ones are those with whom we are currently working, which are providing data. It's mainly for follow-up observations. And the green ones, these are collaborative partners, where mainly our observer Marco Micheli, he calls them, he sends an email, can you do us a favor, can you look at these objects? And recently we also have collaboration with the Russian ISON, the International Scientific Optical Network. This has proven to be very fruitful because they have their telescopes mainly in the Soviet Union. I give up with the laser. So they, when something in Pan-STARRS or Catalina, they discover something, the American radar, the telescopes can't see it anymore, but they will be visible over Russian territory. They are very useful for follow-up observations. So we cover this longitude gap and are in good position to support this. So this is the telescope we want to put in Chile. It's only a 56 centimeter telescope. The first one is already operational in Spain. This is mainly to test our telescope software, the data processing, also the commanding software. So once the telescope will be ready, the Fly-Eye telescope, we hopefully have already the data processing tested. And our biggest innovation in Europe, our contribution to planetary defense, is supposed to be the Fly-Eye telescope, which is currently being built. It has a nice field of view with 6.7 degrees by 6.7 degrees. So this is really a unique asset in the world. If we get it working, it's splitting the beam into 6 optical channels, and so basically splitting up the field of view into 16 field of views. We started in 2016 with the Italian company OHB. It's a European project with subcontractors from all over Europe. And this is currently the status. So it's manufactured in Italy. Turad is close to Milano. And the first alignment of the optical channels is taking place. We see, try again, see here the beam splitter, which has 16 facets. That's why it's called the Fly-Eye telescope, like the eye of a fly. It has various facets, and we get a compound picture, which the software then has to assemble. We have a 1 meter main. Here's the beam splitter again, the reflectors. There is a 1 meter mirror underneath, and this is the equatorial mount here. There. The factory acceptance test of the equatorial mount took place in Verona already last year. And what we are now focusing is on the finalization of the cameras. We want to have the acceptance test in July 2019. We have a ministerial council in end of the year 2019, where we want to demonstrate that this telescope is working, such that we get money for the next telescope. The idea is to put it in Sicily at Monte Mufara at an altitude of about 1,800 kilometers. So we have contracted out the infrastructure contract to build the roads and the dome and everything. So it's all on its way already. It's funded, and it's going to happen now. And if we get green light at the Ministerial Council, we want to have a second fly-eye telescope to put in La Silla in Chile. So if we get the funding, we would also cover finally the southern hemisphere, because if an asteroid is approaching from the south, currently all our assets are in the northern hemisphere, and we might miss this out. So with this fly-eye telescope, the idea is that we scan the whole sky within 48 hours. Because of this huge field of view, we can be much faster than existing telescopes, and then we hopefully are safe against this, or we can at least detect those asteroids which are coming from the night side, and where we can cover the sky. The second pillar is planetary defense, is information provision. So we have to calculate the orbits, do impact probability. Juan Luis Cano will present more information what we are doing exactly there in a few hours. Basically, we have a database in NeoCC where all this information is published. It's on our website. We can basically look up which objects are dangerous. We have currently 850 objects with a probability larger than 0 to impact the Earth. And the third pillar is mitigation. We are working on a fireball network that we put fireball cameras all over Europe and basically observe the fireballs. And Romana already has covered this I1 and same page groups which support the OSA Copus, and ESA is currently chairing the same page group. So we are very active in supporting the mitigation pillar there. So these are the fireball cameras which we also would like to put into space as a hosted payload. When something like this fireball over the Bering Sea happens, that we also have a space-based capability to observe those. We are having a contract on the effects engineering tool, depending on size, angle, speed of the entry of the asteroid. We want to understand what kind of effects this will have. So we have kicked off a contract with Naturkunde Museum in Berlin. They are providing analysis and tools that we will be able to predict the effects if an impact is happening. And finally, again, depending on the positive outcome of the Ministerial Council, we want to have here the Hera mission, which will fly after DART, would look at the impact crater and try to help the modeling of impact of when a kinetic impactor tries to deflect an asteroid, how successful this is, this famous beta factor, how much energy is transferred into the impact. So we would like to fly there, launching in 23 or 24 and arriving in 2026 to look at the how successful DART was. These are the various steps to fly there, observe Didymoon and the craters, measuring the mass of the objects, and really make a rendezvous mission there. So overall, as a conclusion, I still have 40 seconds. That's perfect. We start our operations with the testbed telescopes and installing the second one. The major work is the Flyer telescope #1 and putting it in operation. Hopefully, we get first light end of the year in somewhere. We don't know where we will be initially. Start the Flyer #2, and of course expand our collaboration with existing telescopes. in order to make better observations. We want to build the firewall camera for hosted payloads. We want to continue international protocols with impact threat warning and responses. We're organizing a workshop soon. And we hope that we get the Hera mission funded and that we can fly a mission to characterize better the impact on DD Moon. Thanks a lot. And with my last sentence, let's make our planet a safer place. I'm open to questions. Thank you.
Okay, we'll take one question from the audience. Try to stay a little on schedule here. Oh, GURPS, there you are.
No, I just want to make an announcement. Oh. If just for the sake of the attendees online, if you could just wait to have a microphone brought to you if you can't make it to one of the stage mics. We'll have someone get it to you. Thanks.
Okay. Questions for you, Rüdiger. Can you go up to the mic, please?
Thanks. Oh, it's just a small addition because I wanted to say that the Tautenburg Observatory also became part of the observational network of ESA with our new camera. There's a poster outside, 37, on our new camera, and the first observations will start right away today. So we will contribute to this effort.
Thanks a lot. That's good news. We're always open for new collaborators. Thanks.